Hello everyone and welcome to your lesson for today. Today we are covering Chapter 2, Lesson 1, which is 2-1 and conditional statements. Now there is a ton of information in this section, so you may have to pause the video and write some notes and then start it up again and then pause the video and write some notes. I'm going to go through things fairly quickly on that part of it, so please pause when you need to. As a matter of fact, since Screencast-O-Matic only allows me 15-minute videos, I may have to do this lesson in two separate videos. So let's get going here. All right, conditional statements. Conditional statements are something that we use a lot in geometry. We will refer back to this conditional statements all year long. Your parents probably use conditional statements too. I do with my own kids, especially when they were younger and they wanted dessert. So there would be cake or ice cream or something afterward, but yet they didn't want to finish their supper. They didn't want to finish their hamburgers. So I would say something to the effect about, if you finish your hamburger, you don't have to eat the bun, but if you eat the meat, then you can have dessert. So that is a conditional statement. They can only have dessert if they finish their hamburger. So that's what we're going to be working on today. So a conditional statement here is going to be something that a conditional, oops, my pen's not working, a conditional can be written in the form P implies Q. And we write that as a symbol. P with this arrow between it implies Q. The hypothesis is the P part of the statement and follows the word if. So P is the hypothesis. A lot of times we call that the subject. So if you're thinking of in language arts, when you had to diagram sentences, P is your hypothesis. The conclusion is the Q part, and that is the then. Okay, so in my example, if you eat your hamburger, then you can have dessert. So the subject part of it would be eat your hamburger, and the conclusion part would be get dessert. Alrighty, moving on. So an example would be, and if things are already written, we say that you can underline the hypothesis once. Remember, I said that a lot of times we just call that the subject of a sentence. And the conclusion we underlined twice. Do not underline if or then. Do not underline if or then. So if today is Monday, then tomorrow is Tuesday. So today is Monday, that would be your subject, that would be your hypothesis, that would be the P part. Tomorrow is Tuesday, that is the predicate. That is the Q part. So tomorrow is Tuesday is the Q. So in the second sentence, if today is Thanksgiving, then today is Thursday. Today is Thanksgiving is your P, and today is Thursday is your Q. A number is a rational number if it is an integer. If, do you see how if is right here? So it is an integer is your subject, and it is a rational number is going to be your predicate. So be careful, sometimes they will reverse the order on those. All right, many conditional statements may not be written using the words if and then, but they can certainly be written to follow the if-then format. To do so, figure out which part of the statement depends on the other. So again, the subject is typically the P part, and that is your hypothesis. So all squares are rectangles. So if we think of it, if a figure is a square, then it is a rectangle. If a figure is a square, then the figure is a rectangle. Do not put if it is a square, what is it? So put the figure, the quadrilateral, the polygon. So if a polygon is a square would be very appropriate, but do not say if it is a square because we don't know what it is. All right, and the second one, two angles that are complementary. So if you have two angles that are complementary, then they are acute. Then the two angles are acute. Either way would work. Third one, an obtuse triangle has exactly one obtuse angle. If you have an obtuse triangle, then it has exactly one obtuse angle. So just putting in the if and thens for the subject and the predicate. All right, Venn diagrams, write the statement that is true. So in a Venn diagram, your subject part is typically the inside box. So if you have a natural number, then the number is whole. So in the second one, the violin, this is going to be your P part, and the string instrument is the Q. So if your instrument is a violin, then it is a string instrument. Analyzing the truth statement. So not all if-then statements are true. So you have to analyze each one. So using a truth table, this is a huge thing. So the stuff underlined here in the bottom is the big part. So if your hypothesis is true, you ate your hamburger, then the conclusion would also be true because then you would get to have your dessert. Okay? If the hypothesis is true, you ate your hamburger, but you did not have dessert, then it is false. If you did not eat your hamburger and you did not have it, that is still true. And just because this is false, could it have still happened? That is true. The only one that is going to have a false result, the only time we conclude that we have a false result in a truth table is going to be when the hypothesis is true, but the conclusion is false. So it's when you break a promise. That is when you're going to have a false truth value. Here's the conditional statement. So if something is false, you only need one counterexample to make that thing be false. So if a number is odd, then the number is divisible by 3, and they mean evenly divisible by 3. So if a number is odd, so let's just take 21 and we divide by 3, we get 7. Okay, so some people are like, okay, good to go. So 33 divided by 3 goes in there evenly. We get 11. Okay, what if we take the odd number 11 and divide by 3? Is that evenly? No. So this would be your counterexample. So a counterexample is an example we can give that will prove something false, and you only need one in order to make the statement false. So second example, if an angle is acute, then it is 85 degrees. Well, let's see here. Could I have a 25-degree angle? Is a 25-degree angle acute? So that would be your counterexample. If today is Tuesday, then tomorrow's tomorrow is Thursday. So tomorrow, Wednesday's tomorrow is Thursday. So this one is true. All right, negation. So when you negate something, you are putting basically the word not in front of it. And so how we write that in terms of math is this little tilde symbol. So when we had an equal sign with this mark above it, that means congruent. So if you just have that tilde, it means not. This means not P, not P. So you're just basically putting in the word not if you are going to negate something. So if you have an original statement, if you live in Minnesota then you live in the US. Okay, that is your original statement. This is your P, living in Minnesota, and this is your conclusion, then you live in the United States. So the converse, so this is definitely a place where you are going to want to stop and copy all of this stuff down at the end. So the converse is when you switch P and Q. So we're going to put the Q in front. So we are going to say, if you live in the United States, then you live in Minnesota. Okay, that's what the converse is. You go back to the original and you switch the P and the Q. Now, in the first one, if you live in Minnesota, you live in the United States. Is that original truth value? Is this true? And this is true. Now let's look at the converse. If you live in the US, then you live in Minnesota. Well, that's false, because you could live in California. You could live in New Mexico, Arizona, any of the other states. All right, so now what is the inverse? So go back to the original conditional statement, and you just negate P and Q. So we write it not P and not Q. Whoops, that's a P. Q. All right, if you do not live in Minnesota, then you do not live in the US. Okay, well, let's see. If you do not live in Minnesota, could you live in Wisconsin? Then you do not live in the US. Well, that's not true. You still live in the United States. So this is false. All right, then the last one that we have here, hopefully I can get this moved, is the contrapositive. So we want to switch and negate. Okay, switch and negate. So go back to the original, and we want to say, if you do not live in US, then you do not, wow, I can't write that, do not live in Minnesota. So we want to switch it and negate it. If you do not live in the United States, then you do not live in Minnesota. And that truth value is true. So if you're not living in the United States, there is no way you can be living in Minnesota, because Minnesota is in the United States. So that truth value is going to be true, just like the original one was. So you may need to stop this, pause it, and go back and write everything. All right, so I think I'm going to cut it off here because I only have a couple minutes left, and I'm going to start a new video talking about some of these. Oh, wait, I'm going to finish this. This logical equivalence goes back to what we just did. If you go back to that last screen and you notice I went through the truth values. And if you look here, do you see how the original was true? And so is the contrapositive. So you can see that those truth values are the same. And you see how the converse is false, and so is the inverse. So what happens is the logical equivalence is that your conditional and contrapositive are going to have the same truth values. So if they're both true, if one's true, the other one's going to be true. If one's false, the other one's going to be false. And the same thing happens with the converse and the inverse. Those truth values are always going to be the same. Conditional, contrapositive, always the same truth. Always both true or always both false. And the same thing happens with your converse and your inverse. All right, so now we're going to go through some examples of this right here. So this is where I'm going to start off because I'm running out of time. So we will pick it up again in video 2.